Hey guys, good morning. This is again Mr. Renato Priolo. For today's video, I will be presenting to you multiplication and division of functions. This is the continuation of the topic that I had presented in my previous video about addition and subtraction of functions. So this is on operations with functions. But before that, if you are new to this channel, please do not forget to subscribe and click that bell button below for more videos in the future. Okay, let's start. So we have here multiplication and division of functions. How do we multiply and how do we divide functions? But before that, we will have the lesson objective first. At the end of this video, you should be able to perform multiplication and division of functions. But I have included here the prerequisite skills in performing multiplication and division of functions. We should have our knowledge about multiplication and division of polynomials. We should also have a knowledge about factoring and of course about evaluating functions. So to start, we will go back to the rules in performing operations with functions. So we already have discussed about the sum and the difference of functions or the addition and subtraction of functions in my first video. So for now, we will focus on the product and the quotient of functions. If you are told to multiply the functions g and h, it's just the same as the function g should be multiplied to the function h. And of course, do not forget to always simplify your answers. For quotient, in performing division of functions, so if you are given the function g and h, so divide g over h. We have to remember the restriction that h of x should not be equal to 0. When we say h of x, that is in the denominator. H of x must not be equal to 0 because this will make the whole function undefined. Okay, let's start. If you are giving the following functions, g of x is equal to x squared minus 1, h of x is equal to x minus 1, the f of x is equal to x squared minus 2x minus 15, then you have p of x equals x plus 3, and your q of x is equal to 2 plus x. For example, we are given these 5 functions and you are told to find the following. Number 1, we are to find the product of h and q. So the product of this function h and this function q. But after multiplying these two functions, we have to remember that we need to evaluate the function using the domain negative 7. The same also happens for the second example. If this time we have the quotient, say f over p, the function f divided by the function p. For number 3, we have to multiply the function g and h. Of course, we need to remember about how to multiply polynomials because we will be needing our knowledge about multiplying polynomials. For number 4, we will have to multiply the functions p and q. So this is the function p and this is the function q. And after multiplying the function p and function q, we need to evaluate using the domain 1/3. And for number 5, we need to divide q divided by the function f. Okay, to start with, we will start with example number 1. So again, these are the functions given. For example number 1, we have to find the product between h and q. So then evaluate negative 7. Our function h, our function h is x minus 1. So we write this one by x minus 1. This is multiplication. The period here means multiplication. So we have the function h, which is x minus 1. So you should always enclose your uh, function with a parenthesis to indicate the multiplication operation. So we have here x minus 1, which is our h, and 2 plus x, which is our q. Now, since the h and q are binomials, again, we need to follow the rules in multiplying polynomials. So how do we multiply two binomials? Using FOIL method, we need to multiply the first term x and the first term here 2. Then afterwards, we need to multiply the first term to the second term here, then the second term to first term, then second term to last term. Or the FOIL method, first term to first term, then outer term to outer term, inner term, and last terms. You just simply follow the arrow here. We don't, when we multiply x times 2, that gives us 2x. Then when we multiply x times x, that gives us x squared. Then when we multiply negative 1 times 2, that gives us negative 2. And negative 1 times positive x, that gives us negative x. So here are the resulting polynomials. So again, we have x times 2, that gives us 2x. Then we have x times x, that gives us x squared. We have negative 1 times 2, we have negative 2. Then negative 1 times x, that gives us negative. What must come first for this polynomial must be x squared. Then combine like terms, 2x minus x. So we have 2x minus x is positive x. Then copy the constant negative 2. Then afterwards, since we have the domain negative 7 here, we need to evaluate negative 7 using negative 7 for this function. So the resulting equation now becomes negative 7 quantity squared plus the value of x, which is negative 7, minus 2. Then we have the square of negative 7 is positive 49. Then positive times the negative is negative. So that is negative 7, negative 2. So by performing the operation, 49 minus 7 is 42. 42 minus 2 is 40. So the final answer would be 40. Let's proceed to the second example. We are told to find the quotient between f and p. So our function here, f is x squared minus 2x minus 15, and our p is x plus 3. And do not forget to evaluate your function using the domain negative 2. So to write this function, we have our f in the numerator, x squared minus 2x minus 15 divided by the p, which is x plus 3. Now in this part here, since this is a trinomial and this is factorable, so we need to factor out this trinomial for us to check whether there are terms or factors that are common in the numerator and denominator. Since x squared minus 2x minus 15 is factorable, so we need to factor that out. That gives us x minus 5 times x plus 3. And as you can see, our p is x plus 3. Then we have the common factor in the numerator, which is also x plus 3. So in this case, we can cancel out x plus 3 in the numerator and also x plus 3 in the denominator. Therefore, the resulting function becomes x minus 5. So what remains in this function is x minus 5. So this time, we need to substitute negative 2 to x in this function. So the resulting equation becomes negative 2 minus 5, which is negative 7. So the final answer is negative 7. Next example, 3. Still given the same functions, and you are told to find the product between g and h. So to write this function, we have our g is x minus 2, x squared minus 1, and our h is x minus 1. So by using, since this is a binomial and this is also a binomial, so we need to use the FOIL method. So multiply x squared times x, which is x cubed. Then x squared times negative 1 is negative x squared. Then negative 1 times x is negative x. Then negative 1 times negative 1 is positive 1. So this must be the resulting function. Now, since there are no like terms here, we have x squared, x cubed, x squared, x, and 1. So there are no terms to be combined. So what we need to do is to just simply evaluate the function using 1. So substitute 1 in this function, that gives us the x here becomes 1. We copy the cube, we copy the minus. Then x is 1, we copy the squared. Then we copy the minus. Instead of writing x, we change that with 1. Then we just simply copy 1. Then simplify. The cube of 1, the cube of 1 is positive 1. The square of 1 is also 1. Now, this is positive 1. Since this is the operation minus, so we copy the operation minus. Then 1 times positive 1 is negative 1. Then we copy positive 1. To simplify, we have to combine 1 minus 1 is 0, then negative 1 plus 1 is 0. So the correct answer is 0. Fourth example, we are to multiply the functions p and q. So our p is x plus 3 multiplied to our q, which is 2 plus x. Multiplying using the FOIL method we have here, but again, x times 2 is 2x, x times x is x squared, 3 times 2 is 6, and 3 times x is 3x. Then combine like terms, arrange the terms in descending order of degree. So what must come first must be our first term, x squared. Then we combine the terms 2x, since they are like terms, 2x plus 3x, which is 5x, then we just simply copy 6. Then we simplify, we evaluate this function using the domain 1/3. So that gives us 1/3 quantity squared plus we copy 5 times the value of x, which is 1/3, and we copy 6. The square of 1/3 is 1 over 9. So we have here 1 over 9, we copy plus, then we multiply 5 times 1/3, that gives us 5 over 3. Again, I would like to emphasize here, when we multiply a whole number to a fraction, we just simply multiply the numerator 5 times the numerator, and the denominator, assume denominator of 5, which is 1. So 1 times 3. The most common mistake here is that we multiply the numerator and say 5 times 1, 5 times 3. That is wrong. I would like to emphasize here. Every whole number is assumed to have denominator 1. So we have 5 times 1 is 5. And assume denominator 1 times 3 is 3. Again, we simply copy 6. To simplify, as you can see, this equation now involves fractions. So 1 over 9 plus 5 over 3 plus 6. And 6 is a whole number, as I've said. Every whole number is assumed to have denominator 1. So to perform this operation, we need to find the LCD of these three fractions. So the LCD of this fraction would be 9. So 9 divided by the 9 here in the first fraction is equal to 1. Again, 9 divided by 9 is 1 times 1 in the numerator, that gives us 1. Then we copy plus. We have here the plus. The same things happen for the second fraction. So we have the 9 here times divided by 3. 9 divided by 3 is 3. Then multiply to the numerator 5, that gives us 15. Then we have the 9 divided by the assumed denominator 1 here, that is 9, times 6, that gives us 54. Now we add the numerator, that gives us 70. We copy the denominator 9, so the final answer is 70 over 9. Last example, the same set of functions here. For the last example, we are to divide the function q and f. So this is our function q and this is our function f. Okay, so to write that, we have The function q is 2 plus x. So we have here 2 plus x. And the function f is we have here x squared minus 2x minus 15. So since factors of x squared minus 2x minus 15 is x minus 5 times x plus 3, we have no common factor in the numerator. There is no reason to factor out this trinomial x squared minus 2x minus 15 because there are no common factors in the numerator. So we can just leave it here like this. So x squared minus 2x minus 15, so we will not factor out because there is no common factor in the numerator. So what we need to do is just simply substitute directly the domain, which is 3, to this function. So that gives us 2 plus 3. Then over, this is x squared, so change that with 3, so that becomes 3 quantity squared. Copy negative 2 times 3 minus 5 minus 15. Then we simplify. 2 plus 3 is 5. Then the square of 3 is 9. Negative 2 times positive 3 is 6. Then minus 15. We perform the operation here. So we copy 5. 9 minus 6 is positive 3. Then positive 3 minus 15 is negative 12. Now the correct answer is 15 over 12. Since we cannot simplify or reduce this one to the lowest term anymore. So that's it. Now, I would like you to try these examples at home. Just practice this at home. So if you are given these functions, h of x equals 2x and f of x equals 5 minus 3x and g of x equals x minus 2. Try solving this function, this operation. So I hope you have learned something in this video, but before that, I would like to leave this with you. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. This is by William Paul Thurston. So, what we need to do in order to understand math is, of course, we need to understand every situations in mathematics. For that, good day and goodbye. By the way, do not forget to subscribe for more videos in the future. Thank you.